Okay, so what we did here, just to recap for everybody that was at home, we're plugging in 1, 2, 3, 4, 5, 6 into this formula. So if we're looking for the first term, n equals 1, and we plug 1 into this formula, negative 4,000 times negative 1 over 4 to the power of 1 gives us 1,000. Then for the second term, n equals 2, we plug in 2, and then 3 and 4 and 5 and 6, and these are the values we get. Now we're going to plot these on our graph. To do that, I'm going to have to adjust the values a little bit, but I can get away with just making this into 1,000 and 800 and 600 and so on, and the same thing here. So we just want to see where the values are approaching. When n equals 1, my value is 1,000, so we are all the way up here. When n equals 2, I'm at negative 250 here. N equals 3, I'm at 62.5, so we're alternating between positive and negative. Then we're at negative 15.7, closer to 0. Then we're at 3.9, even closer to 0. Then we're at 0.98, even closer to 0. So as you can see, what's happening as the terms progress?
They're converging.
It's going to converge. The numbers are approaching a value of 0. Okay? That means this sequence converges. Okay?
Do we need a graph though?
Yes. All right.
And do we just stop at the... No, I mean, draw the line.
Oh, no, you don't connect the points because these are distinctive terms. Don't connect the points. So let's take a look at the second sequence. All right, for the second sequence, we're going to do the same. We want to find A1, which is equal to negative 2 over 2, and that's negative 1. A2 is negative 2 squared over 2, and that's equal to 4 over 2, which is 2. Now, A3, in this case, n is equal to 3, so we're going to put 3 in here. Negative 2 cubed is negative 8 over 2, negative 4. A4 is negative 2 to the power of 4, which is negative 16 over 2, negative 8. A5 is negative 2 to the 5, negative 32 over 2, negative 16. No.
Yeah.
No. This is positive, and that's negative. And A6 is negative 2 to the power of 6, which is 64 over 2 is positive 32.
Can't we just fill it in when we get to like A4? We can just realize the trend.
Right. So I will specify on the test how many you would need to find. But yeah, once you know the trend, then you can stop. So at first we're at negative 1, then we're at positive 2, then we're at negative 4, positive 8, negative 16, and so on. And as you see, as the terms progress, the values are getting further and further into the infinities. That means this will diverge.
Wait, why does it diverge?
Because as the terms progress, the numbers are getting bigger and bigger, so they're going into the infinities.
And then
eventually.
It converges if it gets closer.
It converges if it, not closer to 0, if it will, if it will approach a specific value. It doesn't necessarily have to be 0. They could be approaching 1 or 5 or negative 2. All right, so let's take a look at this one. A1 is going to be 0.1 times 1 over 2 minus 1, so it's 0.1. A2 is 0.1 squared times 2 over 3. A3 is 0.1 cubed times 3 over 2 times 3 is 6 minus 1 is 5. A4, 0.1 to the 4 times 4 over 7, and so on and so forth. So now we have to find the values for each of those terms. So we find these values to be 0.007, 0006, 00006, and if you attempt to graph it, you already see that they're just going to keep getting closer and closer to 0, so this one also converges. So far we talked about what a sequence is. A sequence is simply a list of numbers. Now, if you take the list of numbers, and if you now proceed to add all of those numbers, then what you have is a series. So as a series is the indicated sum of all the terms in a sequence. And just like we talked about before, a finite series is the sum of a finite sequence, and an infinite series is the sum of an infinite sequence. This is a visual representation of what I just said. If you have a sequence, which is finite, if you add them all up, then you have a finite series. If you add up the terms in an infinite sequence, then you have an infinite series. Now, sometimes what we need to find is the nth partial sum. This just means the sum of not all the terms in the sequence, but the first 5, or the first 10, or the first 4. That's nth partial sum. And the notation for it is capital S subscript n. So to find the nth partial sum, you find all the terms up to an. So for example, if you were finding the 6th partial sum, you find the first 6 terms, then you add them all up. All right, so let's try them out here. We want to find the 5th partial sum of an equals n squared minus 3. Because it's the 5th partial sum, I want to find the first 5 numbers. So I want to find A1, A2, A3, all the way to A5. When I'm looking for A1, what is my n? 1. So it's going to be 1 squared minus 3, negative 2. A2 is going to be 2 squared minus 3, 1. A3 is going to be 3 squared minus 3, 6. A4, 4 squared minus 3 is 13. A5, 5 squared is 25 minus 3, 22. These are the first 5 terms. If I want to find the 5th partial sum, that's S5. And now what I want to do is just add these up.
40.
Okay? So negative 2 plus 1 plus 6 plus 13 plus 22. 40. Okay? All right, so let's do this quickly. We want to find S4 of this. So we need A1, 6 over 2, 3. A2, 6 over 2 squared. Okay? This is 6 over 4, which is 3 over 2. Six over 2 cubed, 3 over 4. And A4, 6 over 2 to the 4. That's 6 over 16, which is 3 over 8. Yes?
Yes.
So S4 is 3 plus 3 over 2, 3 over 4, plus 3 over 8. And you will specify them in either decimals or fractions, depending on what the specific directions will ask you for.
5.6.
How much is it?
5.625.
5.625, exactly.
Or 45 days.
Now, for the page
It's actually 90 over.
Let me see.
No, it's not.
90 over 60.
Don't you see that in a lot of fancy math? That notation?
Okay.
It scares me.
All right. Now, so we use S to mean sum, right? But this notation isn't very helpful if we want to find if you want to find the first four numbers, the sum of the first four numbers, or the sum of the first however many numbers, it's fine. But if you want the sum of, let's say, the 10th to the 15th number, this notation is somewhat limited. A more general notation is what we call sigma notation. Sigma is one of the Greek letters. It makes the S sound, and it's written like this. This is capital sigma. Lowercase sigma looks more like this.
If you turn it sideways, it looks like an M.
Right.
Or a W.
Or W.
So what we use is an index here. N equals 1 to k, meaning sum up all of the numbers from the first to the kth. So if I want to find the sum of the first four, it'll be n equals 1 and 4 up here.
And do you multiply that by whatever? Because actually the next one, there's something multiplying that after you add all those numbers up, you multiply that by the n.
No.
By that? Oh,
Okay, so here's what we're going to do here. We need to find the sum of the terms of the first four terms. So again, let's find A1. N is 1, meaning we get 1 squared minus 1, 0. Now, A2, N is 2, so I get 2 squared minus 2, 2. A3 is 3 cubed minus 3 is 6. And A4 is 4 cubed, I'm sorry, 4 squared minus 4, 12. So the sum from 1 to 4 of so this was 12. So the sum is 0 plus 2 plus 6 plus 12.
Wait, do you want us to?
And that will be 20.
Do we need to write out the...
That's it. To show work, you should. Finally, the last two are as follows. Now here I want to go from n equals 2 to n equals 5. So I want to find A2, which is 3 times 2 plus 3 over 2, and A3, which is 3 times 3 plus 3 over 3, A4, 3 times 4 plus 3 over 4, and A5. So here I will get 6 plus 3, 9 over 2. 9 plus 3, 12 over 3, which is 4. 15 over 4. And A5 will be 3 times 5 plus 3 over 3. So it'll be 18 over 3, which is 6. The sum then, n equals 2 to 5 of 3n plus 3 over n is 9 over 2.
Wait, I don't think A5 is...
Yeah,
It's over 5, so it should be 18 over 5.
Oh, 18 over 5. I was trying to rush.
So 13.777666.
So the sum here is 15.85.